Hello, Algebra 3. This is going to be a lesson on section 3.3. We're going to be looking at linear functions and their graphs. In the next section, and I believe the next section is going to be over similar stuff, linear functions and graphing them. But we're going to be looking at a few aspects in this one that aren't covered in the next two. So let's get started on it. So here is what a linear function looks like. F of x equals ax plus b, or many times you will hear me say mx plus b because that's what we're used to seeing in previous algebra classes that we've been in. M is our slope and b is our y-intercept. But here we go. We're going to look at some more stuff. All right, in this section, the way we're going to graph our linear equations is by using the intercepts, the x-intercept and the y-intercept, to help us in graphing our linear equations. Because all we need is 2 points to graph a line, and one is going to be the x-intercept and the other one is going to be the y-intercept. So ways to find these two things is to find the y-intercept, what you need to do is plug 0 in for your x value in your equation and solve for x, or solve for y, sorry. And then the way to find your x-intercept is by putting 0 in for your y value in your equation and solve for your x value. So let's do an example of that. Alright, so here we have an equation and we're asked to graph this and then give the domain and range. But before we graph this, what we're going to do is find the x and y intercepts. So remember, for the y-intercept, what we do is I'm going to replace this with a y and then write out my equation like that. Remember, y-intercept, we plug in 0 for our x and solve for y. So 3/2 times 0 plus 6, well, that's going to give me that y is equal to 6. So what this means is we can plot the point 0, because that's our x value, 6, and that's our y-intercept. And our x-intercept, this is how we're going to solve for it. We're going to plug 0 in for our x value, or sorry, our y value. So I'm going to go ahead and set it equal to 0 equals 3 over 2x plus 6. And then we solve for x. So go ahead, subtract the negative 3/2 on both sides. And then that will give us x equals, now I'm going to multiply both sides by the reciprocal. That's what I'm doing. So x equals 6 times negative 2 over 3, which is negative 4. So right there is our x-intercept at x equals negative 4. And what this means is we're going to plot the point negative 4, 0. Because we plugged 0 in for our y value, that's going to be our 0 in our xy coordinate point. And then we ended up getting negative 4 for our x value, so that's how we get that point. Negative 4, 0, and also 0, 6. Okay, so let's plot these points. So here's the points that I solved on the previous slide. We're going to plot them. Negative 4, 0, negative 4, 0. It's going to be on the x-axis somewhere. And then I'm going to plot that in blue. And then our y-intercept is going to be on the y-axis somewhere. So 0, 6 is right up here. Now, just draw a straight line through those points there, and you have your graph of your linear equation. Another thing we were asked to do before I leave this page, though, is that we were asked to find the domain and range of this linear equation. Well, the domain and range of any linear equation that is not vertical or horizontal line, meaning straight up and down or going left to right type of line, is always going to be all real numbers for both domain and range. Okay, so domain, let's go ahead and state it. All real numbers, or negative infinity to infinity. Range is going to be the same thing. Negative infinity to infinity. And we're done. Now on this one, we're graphing a horizontal line. Remember, horizontal line, it goes left to right or side to side, however you want to look at it. And what we're given is that the graph of our function here is a horizontal line at y equals 2. Remember, you can replace f of x with a y. And how we're going to plot that is at our y equals 2, we graph a straight horizontal line at that y value. Okay, and there we have our horizontal line. To give the domain and range of this, the domain of a horizontal line is always going to be all real numbers. So negative infinity to infinity. And then the range of the horizontal line will always be 1 point. So we're going to write it in a set, and that point is going to be your value that you just plotted on that y-axis. So 2 in this case. Alright, and that's the domain and range of a horizontal line and how to graph one. Now, graphing a vertical line, remember, this line here is not going to pass the vertical line test, so therefore it is, because it is a vertical line, and therefore it is not a function. So, but still, we can always state the domain and range of things that are not functions still. But, okay, so this graph is at x equals 5. How we're going to draw that on our graph here is at x equals 5, this point right here that I just plotted on the graph, we are going to draw a vertical line at that point. And that is our vertical line graphed on our graph. And for domain and range, the domain for a vertical line is very similar how you found the range of a horizontal line. So the domain for this one is just going to be the point in which x is equal to. So it's equal to 5. So we're going to put it in a set, just like that range in the last example. Just like that. Wherever your x value lies, that is your domain, that single value. Now for the range, well, the whole y-axis is being covered by this single line here, going up and down. So our range in this case is negative infinity to infinity. And that's it. All right, for this example, our equation is in the form of, this is called standard form, where it's in ax plus by equals c. And again here, the easiest way to go about this one is finding the x and y-intercepts. Let's find that. Y-intercept. Remember, you plug in your value of 0 for x and solve for y to get your y-intercept. Well, here we're going to get that our y-intercept is 0. Well, we're going to get the same thing for our x-intercept. In this case, let's just show that work for it though. Remember, for x-intercept, you must plug in 0 for your y. And see how we're going to get 0 for x value. Well, if we plug in 0 and it end up getting 0 for our y, that is going to give us the point 0, 0, the origin, which is both an x and y intercept. So to be able to plot another point on this graph, we just need to find another point that is within this equation. So just say something like, pick an x value, so let x equal, let's say, 2. And we're going to find where the y value for where x is equal to 2 by plugging in that value of x. So just pick an x value and solve. Okay, so now we've got this y, for y equals, let's see, that's going to be negative 6. And let's see, y equals negative, oh, not 2/3, 3/2. Let me erase that. (3/2), or you can say negative 1.5. So plot that point. You have the point 2, negative 1.5, the graph. 2, negative 1.5, which is right about here. And there you have 2 points that you can use to draw your linear function. And there we go. Alright, so that is actually, I think, all I have for you. Let's review just a little bit though. So in the next section we're going to learn something called the slope, and you'll see this same thing again, that the slope is equal to the rise over the run, or the change in y over the change in x, which means this right here. Whoops, sorry. Which means this right here. We're going to be using this formula right here to solve for our slope. And the slope, it actually becomes very important when graphing your linear equations, and it's another method of graphing them. And now this is something that you really need to remember, is that the slope of a vertical line is undefined. So remember, vertical line is not a function, so that's how you can remember, not a function, therefore the slope is undefined. Okay, so if you have an undefined slope, just note this is a vertical line wherever my x value is for whatever you're given. So if you're given that x is equal to 2, it's a vertical line right there at x is equal to 2. And then for a line that has 0 slope, this is a function. It's just a horizontal line wherever your y value is for that particular function that you're given. So that is it for this lesson, and I will see you all in class